So phenomenal to be here. To give you a very quick hint on who is ING, where we are heading, and why that, I would say, perspective matters to our discussion like the ones that we're having here. ING, large organization, 15 engineers, internals, and about another 5,000 externals. You see 3,000 tribes, 400 squads, so sizable. And why does that matter? Right? It matters because size makes engineering different. I think you also saw this video at the beginning with Accelerate, with the 2 cars, I guess. Did you notice something in the video? There were no other cars on the street. So it's easy to accelerate if there is nobody else on the street. Right? Now, in an organization like this one, the street is full of cars and animals and trucks and people, and it's a crowded place. And that's the key message. So the challenges that you see here are the challenge that we face when doing engineering at the edge. Right? Silos emerging, geopolitical reflections, can we trust the US clouds, cost, token consumptions, right? So we see the value, we see the tokens going out, and we see the invoices coming in, and the numbers are staggering. So what happens here? Right? So how do we manage that? How do we avoid an explosion of cost? Or reliability, right? So how do we protect, at the end of the day, the expectations of our clients, which are evolving themselves, in getting a service all the time as expected? And how do I change and move and touch everything while protecting this one? And also my hot one, critical infrastructure. Banks are critical infrastructures because in the sequence of bad things that can happen, not being able to do payments in a society is seen as a critical challenge. So the key message here is ING, large organization, so a phenomenal lab to touch and to think about what it means to accelerate when you have guardrails, when you have crowd on the street. We have a conviction, and I will not read the whole sentence, and it's a conviction that written like that is, of course, scalability, of course, reusability, all the parameters that tick the line. Now, that is easier said than done. It's easy if you have an empty data center and no history. Then you can start with a sound principle. But the moment where you have, like us and like many others, you have a data center that looks like the Star Wars bar, if you remember that visual, it's very hard to do that because that's a transformation. Shifting left, yeah, sure. But then you have to have a ready left to shift to, so to say. Right? So it's a transformation. It's a journey. It's more a directional ambition than something you can just switch on and make it happen, because history matters and legacy even so. Same applies with everything as code. And by the way, when you say everything as code, we are thinking already one step beyond infra as code or CLI all over the place. We are trying to think, what does risk as code mean? We are a regulated industry, there's a hell of a lot of controls. How do we make them code? Not automate them, make them as code, right? So the reflection here can really go far, far, far. A bit of history on what we experimented and with the walls that we found. So we started with the classic waterfall, like all banks in the universe, essentially. The rigid model, we ended up with rigidity. By the way, this is not a plaidoyer against waterfall. There are cases where waterfall is ideal, right? But at scale, we faced massive rigidity. We went into agile, so we tried to really break all the rules and create small, very fast, very independent squads. In our case, you see the numbers before. What ended up? We accelerated the creation of new things, but the moment of bringing them into prod was as slow as before. So we experienced an imbalance because that velocity was not all over the place. Then we went into DevOps, right, where we created squads that included operations and responsibility for prod. Now, phenomenal, spectacular, what it created, complexity. To me, we are at the end of the dream of the full stack engineer, because with 3,000 squads, all of them with full stack engineers, if every squad is designing their own pipelines, their own infrastructure, their own stack down almost to metal, you can imagine what you get in a data center, right? You get 3,000 different views of the world, or more, 3,000 plus one probably, right? So that level of complexity cannot grow further because it is becoming paralyzing, right? Now, agentic AI is popping to the equation. spectacular technology, right? So I'm very skeptical of marketing because we have seen in the past years multiple times the technology that changes the world, and it never happened, except a few times. And AI might be one of those times, right? Because the power is definitely there, but it will not be as it is sold today. It will not be as it is sold today, because looking at the history, if I just accelerate and let more complexity get into it, I'm not solving anything. I'm not solving anything. So that's the work in progress we have here. The key message here is we need to be careful with autonomy, because at scale, absolute autonomy is toxic, right? Absolute autonomy is toxic. There are a couple of consequences that I touched briefly. I mean, complexity becomes exponential and is really paralyzing, or even worse, generates vulnerabilities. Vulnerabilities in cybersecurity term, but also in reliability, resiliency, and all the the terms that are not directly business feature related, or cognitive load. Our engineers sometimes feel like they are in front of a Mikado tower, 10 meters size, and they have to pull a single stick below. How much do you have to know to pull the stick without crumbling the whole tower? So that cognitive load is also a consequence of complexity. And there is no architectural answer, there is no process answer that can take the complexity away if we just accelerate without control. Right? Last bit, efficiency, costs. Complexity has a price. Right? So we trade velocity and local optimization for macro slowness and higher cost. Right? So you see, these are the dilemmas that we keep being faced with. Now, agentic AI has the potential of making it even worse. Agentic AI is a bit on the verge of either becoming a sort of Excel on steroids, right? So end user computing plus, which essentially means a disaster, or it has the potential of becoming an absolute superpower for professional tech infrastructures and engineering. And now you see how even the big model providers are a bit uncertain how to do it. Because if you look at the market, we're in a phase of land grabbing. They're all trying to get as many clients as possible. And how do you do that? Well, by giving goodies to individual engineers and to individual people, because adoption will create presence. Now, that is what happens with some of the end user platforms, but it is full of holes. Take an example. I had a conversation recently with somebody about how do I control what a model or an agent is producing? And the answer was, put your desired controls in the context and the model will respect it. And we've heard that before. Right? So it's a famous trust me model, which never works. Right? What works is a segregation of responsibilities. Right? And that's what we are exploring with specialized and segregated agents. Today, the big segregation we have is the one business or AI for business agents are currently on one of the major platforms. AI for engineering is on two others. Right? And I want to have them segregated because this way I have a minimum level of segregation. The third family of agents, I use models and agents in an interchangeable way, but agents will be control agents. Control agents because I need to have a category of agents that engineers cannot touch. Not in the code, not in what the agent does, not in the moment where the agent acts. Because only so I can guarantee that segregation of duties that ensures my stability, my non-functional requirements in prod, and also my level of control in the platform. So that's a very hot one. Guardrails are not simply punitive. Right? So guardrails is not, don't do this because I fire you. You might remember when you started coding, when we were compiling the first chunks of code. I don't know if it is like this with Python again, but let's say the ones that started a while ago, you got syntax error, right? So you forgot something. And then you don't have to negotiate. Either you fix it or you don't continue. As simple as that. So these controls are the guardrails that have to work. There are also guardrails on the SRE role, the control loops, socio-technical system. There are plenty of guardrails, but the hard ones are not punitive, are just unavoidable. You commit your code, you don't respect the rules, you don't go on. Full stop. It's not a matter that I don't like you, that you're wrong, right, whatever. It just, it's gravity. Gravity pulls down. You cannot have it pull up. That requires, and that's my last bit, a sufficient level of SDLC maturity. You have to have an automated way from repository to deployment, and ideally in prod, because without that underlying stack, it's very hard to deploy anything of this control. So the paradox is that the ones that are more modern in their SDLC process are the ones that will be able to benefit from AI the most. And don't believe in vibe coding. Don't believe in vibe coding. Vibe coding is the Excel version of coding. Of course, there was VBA and macros. Is that coding? It's not. Sorry, that's a bit... platform engineering, and that's the next part of the answer after SDLC. So platform engineering essentially enables us to focus, and it's the next generation or the next engineering paradigm after the full stack engineer. We are starting to separate our engineering population in engineers above the platform and below the platform, and then the ones inside the platform. Right? What does it mean? The engineers above the platform do not have the freedom to design how products and components work and function. They have the freedom of orchestrating them, integrating them, combining them, whatever it takes to deliver business value. The engineers below the platform are the ones that productize what has to be consumed in a platform. And that includes agents for engineering, it includes infrastructure, might include agents for security, right? So all the elements that have to be consumed. And then engineers inside the platform are the ones that essentially orchestrate the SDLC in a platform engineering time. I will not bore you too much with this one, but essentially platform engineering is the next step that we are planting to try to balance that SDLC automation that does not have, I would say, or has too much autonomy in the organization. And then, yes, you automate, but you automate in many different directions. We are trying now to focus back to this. Important message, platform engineering is connecting three big chunks of our story. The first one is infrastructure, because infra has been trying to productize, partially very successfully. Right? So we have a very large on-prem private cloud, which is cloud native for parts, and for others it's not, because if you operate a mainframe or even a mainframe application into an x86 machine, there is only so much you can cloudify, so to say. Now, the big story behind infrastructure is that here we have been fooled by marketing once more, because cloud providers have been telling the story, move to cloud and become cloud native. And so everybody was registering like, well, cloud is an infra thing. Cloud is an application transformation thing, because infra is just an enabler for a different family of application architectures. And you would all nod and say, well, obviously not, if you look at what I have in the data center. Because a piece of software designed 30 years ago or 20 years ago was not built on architectural principles that can be taken over in the next phase. Architecture. AI is the return of architecture. Architects are no longer the PowerPoint gurus that tell you how the world should look like, and then you don't care, you move on what you believe. I'm exaggerating a bit, but this is a bit how architecture felt in some places for a while. Architecture now is really setting the technical guardrails for the platform itself. So it's a return of architecture. Side note, there is a huge problem, because today, people in this room, the architects we have, are the last generation that had to do it themselves. The next generation of engineers are delegating a hell of a lot to the machine. Where are they going to learn? How do I get my next seniors and my next architects if the basic work has been delegated to the machine? Huge question mark. Didn't find an answer yet. And the last one is security. Right? Platform engineering is what brings together these invisible souls of tech that have been so crucial and core, but frequently so neglected to the altar of velocity. So, last comment, platform engineering is a tentative to optimize and balance. Right? On the one side, I need to deliver business value. And on the other side, I need to have a developer experience or engineering experience that is conducive to creativity, to exploration, to innovation, to speed, to control, to all of this. And platform engineering is, we believe, is the answer to that part of the story. So, I guess today is April 1st, so they put a CTO in front of you, but tomorrow is a real day. Go check out Jacopo's presentation. Jacopo is one of our most talented engineers, and he will talk you about the laws of scalable engineering, so how to make it happen. So that was my very short keynote. Thank you for joining. Thank you for being here. Use the event. Use it to get to know new people, get new ideas, and keep ING in mind.